Okay, so what's that? The video I did yesterday was not the video I actually intended to put out. The video I intended to put out was actually going to talk about how the security works in PolyMorphOS and how it's actually kind of scary how small it is, everything it's doing, and just the level of security here. Because what I've set up is if you don't have a key, you don't get in. Okay, and every file has its own key as well, you might say. So it has its own kind of uh, it has its own hash bit. It has its own encryption that has to get checked and verified against who's attempting to use it. So let's go ahead. I have some mouse issues here right now. I've been working out, but I'll show you. If you go to the edge of the screen, you can see well, you can't see it, but my mouse leaves the screen. So anyway, right now, this is the desktop for PolyMorphOS. Okay. Starting down here in the corner, we have the Gravity Well, or essentially your app launcher. This is where the apps reside. You can click this app and it'll launch another terminal. You can see here. So I can move that terminal out of the way. I can make it bigger. I do have a pause that I'm still working out. It's all tied together with the mouse. I'll get into it later. Anyway, and I can shrink it down to this little dot. So these dots are essentially what you're working on. So this is your desktop, right? So these are all things that I have, windows I have that I'm working with. I might have that in there. So this is actually my login window that I had. This one I ran the WASM test app, which you can see it sticks in the window here. It doesn't draw exactly, but it draws so fast that I literally have to turn the rendering down by billions of clock cycles just to see the animation play out. It's so ridiculously fast. Again, we shrink them down, they become these little sparkles. You call them stars or sparkles, however you want to look at it. And all of this is what you're seeing doesn't look impressive, right? In the sense of, oh, we have stuff looks way better than this, John. What are you doing? But each one of these items you see on here, including the text, is being drawn by what's called a Gaussian splat. And I've kind of adapted that a little bit even. It's now what we call an infinity petal, which is a Gaussian splat where you've twisted it. We've applied a pinch in the middle basically, which we can slide up and down. And we can use the ends to inflate or shrink as well as pivot it on its z-axis. So what we get is a three-dimensional hourglass shape type thing that allows us to shrink and move and adjust it and turn it in certain ways. And this is why we call it an infinity petal. One, it looks like an infinity symbol. It's based on the infinity symbol. And two, using this petal allows us to actually reduce the floating point math we would normally use with the Gaussian splats and just do straight integer math. The way the fall off works with the petal is actually easier in the math than doing it with a Gaussian splat. So this isn't just Gaussian splats. This is actually a petal shape that is being twisted and formed in a three-dimensional space to render things like the window you see here, or these little orbs, or this dock, or these little desktop switchers right here, which, by the way, my hitboxes are off. I got to readjust my math because when you deal with a three-dimensional space, the z parallax, the z-axis, messes with your stuff. So try to work this stuff out. But you can see each one of these is separated in their own space. These are all separate workspaces. You can move. I'm doing the copy and paste right now, so you'll be able to copy and paste across your workspaces as well as individual instances of this that you run from within inside it. So I haven't gotten the launcher and stuff set up yet, but you'll be able to run secure, or your AI will be able to run secure instances of PolyMorphOS from within PolyMorphOS that it can do stuff in, get results from, and not destroy your actual working computer. So this is really important, and all the security that's involved. I'm gonna try and make it as easy as possible for everybody, but I mean, really, we're getting to where it's like you're carrying a card or a key of some type, that basically passes your key along. USB key. This is actually really common in most large corporations. Um, let's see. So we got into some of that. So that's kind of the thing about the graphics, right? Is this is so insanely lean that I'm actually running this right now with no graphics card, barely taxing the processor. I mean, it's insanely, it's incredible. So yeah, just the bare metal use of this. By the way, this is right here is a WASM app. It's a WebAssembly app. So I'm setting that up. I'll be doing that more before I release version 0.8. So that basically you can write in whatever language you want, and you'll have a safe application sandbox area that'll run your app, that'll have access to the system as appropriate, of course, and be able to do the things that you want it to do as an application without having to learn a whole new language. Okay. I do understand the barriers there very much. I've worked in the industry for a long time now and understand what it takes to get those things going. I think it's better if you can all just write in the language you're comfortable with. We'll release a SDK, which I've already been working on, and then you'll be able to just use the SDK, compile it right to this, and you'll be able to just basically drag and drop your app right onto the desktop here. So, of course, if you have proper permissions. So, that's some of the interesting stuff here. Where was that one? There we go. So in this screen, and I don't have resize done yet, I'll get to that, but in here you can see my key, which doesn't matter because this is a test drive. I deleted, the key's gone, so don't get excited. You can see we instantiated our 3D desktop substrate. We issued perceive. Now perceive is the first test of our MICT tensor that we've established here. And so what happens is inside the OS, instead of a file or the window itself is being part of the atomic structure, you might say, the tensor now becomes the atomic structure. And this test you see in front of you shows that we can do this. Okay, so because the Gaussian splats are all math, they're all vector-based math, like a SVG, we can take that and just apply it right to the tensors. And the tensors and stuff that I build are based off of base 60 vectoring. And so this maps really well for 360-degree, three-dimensional spatial recognition type stuff. So that's where this all goes into. So eventually we'll move it past the desktop. It'll use cameras. It'll be able to see and map out the Gaussian space and basically kind of see the way that we see, essentially, but it'll see it in math. So that's all stuff I'm working on. I've already got it set up. I've already got the AI architecture designed for all this. And so essentially, once the OS is done, what I'll be doing is taking that OS architecture and training it against the OS, against the Genesis curriculum that I've provided on GitHub that I put out there, so you can see it's all phase staged logic stuff. It's not, I'm not training it on Reddit. I'm not training it on OnlyFans. Okay. Well, I mean, I can watch video. So, ladies are in trouble. So maybe not. We'll see. Who knows? This is the weird part. It's when you start thinking about how this can all interact and work, because it, it allows us to have these tensors and for them to be so small and represent so much in so little means that we can literally transmit them across the internet. And in one of the posts I just put up, you may have noticed I talk about like what it was, like the dream stuff. Well, that networking is how we're going to do networking. Like default will be the standard stuff that everybody uses now, like JSON, HTML. But if a PolyMorphOS is talking to a PolyMorphOS, I'm getting the camera. Or if PolyMorphOS is talking to a PolyMorphOS, they're going to transmit cognitive state. They're going to exchange thoughts, you might say, with each other and adapt. I mean, they can adapt across the board. So this is a very interesting thing. It's not just a hobbyist project. It's actually um, something that's very important to me. It's something I've wanted to make for a long time as far as a adaptable operating system. But the AI and the full MICT theory, actually the full MICT theory is what's really made this possible. The AI has just given me access to the information I needed to work on it, essentially. Um, so yeah, so that is the PolyMorphOS. Some of the major points, it is really locked. So once I get the copy and paste in here, you'll be able to copy your key, and you'll be able just to click Control Z real quick, and you'll be able to log in, and it all wipes as soon as you go away. Um, but yeah, so this is all being done right now on 4 CPUs. It's barely using CPU. It runs about 100 megs of RAM in total. And I've popped these windows open over and over again. So, and we can even do a little, let's see. Sometimes the UI is a little funny. Oh, that's right. Make that one big. Get down again. No, close that one. Now we'll have some fun. So this dock down here, the reason this dock is here is because these are the applications you're using right now within this desktop space, within your workspace, right? So I don't use it to open the most recent one or anything like that. In this instance, this dock right here is there so you can open a new instance of an app you may be working on already. And then if you want to work on a different app, you come over here, you get the app, it pops up down here in your floating dock. So right now I'm just opening Windows. I'm just giving you an idea of like how many of these things I can open up right now on here, right? And keep in mind, each one of these is rendering about, what, 1,000 or so of those Gaussian splats I mentioned. So what are we up to? 10. Nothing's even slowing down. I mean, oh wait, I decided I want change my mind. I want to go work on something else. We'll come over here. We'll open some. I mean, this is what I'm saying. This is a bare metal OS that's rendering 3D Gaussian splats, which basically means once I start adding more of the depth and parallaxing in, you'll get that holographic effect from them. But you can already kind of see it in how they overlap and stuff right here. So, oh, keep in mind that's instance 15 I just opened. And so we'll go back to desktop 1, wherever that clicker is. There we go. So I've got a bunch of them over here. I've got a bunch of them. Okay, you see it's off over here, none over here, and these are all separate desktop instances, so they don't overlap with each other. So that's pretty neat stuff. Oh, you know what? I could probably open. Let me grab a window somewhere here. We'll do run, and then you'll be able to kind of see the thing go. It's in the background. Here, we'll go back over here to this one. And let me close some of these real quick. Oh, that's funny. All right. Yeah, this one's in a good enough spot. We'll do run, and there you go. And so it goes that quick. It's actually an animation that's supposed to play out. I think I have it slowed down to 200 million cycles per frame, and that's still how fast it goes. So, yeah. That's been the demo. I've got more coming, more I'm working on and building this up. And yeah, this will be a functional OS. This is going to be just, for lack of a better term, beyond badass.